Okay. So Chrissy runs the stairs at her office for exercise. Yesterday she started 10 meters from the ground floor and traveled up at 4 meters per second for 15 seconds. Then back down at -6 meters per second for 12 seconds. We're supposed to produce a velocity versus time graph and a displacement versus time graph. So this is her velocity versus time graph information. And so we have to take a velocity versus time graph and convert it to a displacement versus time graph, or a position versus time graph. So the first thing we do is they give us her starting point. It says she starts 10 meters from the ground floor. And that's positive 10 meters. So they give us the starting position. Okay? So they also give us the rate, 4 meters per second, that she travels for 15 seconds. Right? And we know from a velocity versus time graph that the area of the graph is the displacement. Okay? So we can figure out the positions once we graph the velocity. Okay, so first thing I would do is I would figure out how much time do I need on my velocity versus time graph. Okay, let me repeat that. First thing I would do is figure out the time on the velocity versus time graph. We have 15 seconds that we need to represent, and then we have 12 seconds that we need to represent. So that's a total of 27 seconds that we need to represent. And so I'm going to put my velocity versus time graph here on the second one, and I'm going to count my numbers. And I believe I have 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I got 16 spaces, and I got 27 seconds that I need to represent. So there's 27 seconds divided by 16 spaces. Okay? That's less than 2. Right? 32 divided by 16 would be 2. So 27 divided by 16 is less than 2. Right? But it's greater than 1. So I'm going to use my laying the foundation technique, and I'm going to round this number up so that I have 2 seconds per space. And that's going to be my intervals. The reason I bring this up is because some students are having trouble with their intervals. Okay. Okay. Okay, so, pardon me? Okay. So yours is 2.25, so you would round to 5. Yes. So each one of your spaces is going to be 5 seconds. Okay? Or you could, here's something else that you could do. You could kind of twist the rules a little bit, and you could say that every 2 spaces is 2.5 seconds. That might be better for you. Would that work? Let's see. I'm sorry. Every 2 spaces would be 5 seconds for you, because you have less spaces than me. Your graph is different than mine. So if you go every 2 spaces is 5 seconds. Okay? And that'll work. So let me go ahead and number that. So I've got 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. And this is time in seconds. And then we've got velocity over here. And velocity is going to be in meters per second. Now, we have 2 velocities we have to represent, 0 and -6. There's a difference of 10 between -6 and 4. Okay? So, our numbers again are 16 for mine, and they're probably 12 for yours. So I'm going to say 10 meters per second is the amount that I have to represent, and I've got 16 spaces. Okay, so I can my number is going to be less than 1. Your number is also going to be less than 1. So you can round up to 1. So you would count by ones. Now, in order to capture -6, you got to start at -6. Okay? So I'm going to go -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. Okay? And you would on the lines. Okay, so the first velocity is 4 meters per second. It's constant for 15 seconds. So I'm going to start at 0. I'm going to be at 4. And then I'm going to go 15 seconds, which is halfway between these two because I counted by 2s. And I'm going to go to here. That'll work because you got 10 meters per second. So start at -6 and count by ones, and you should get up to 4, which is what you need. No, I just had extra space. So yours turns out perfect. Okay, so this is my first velocity right here. It's constant. My second velocity is -6. And it's for 12 seconds. So I go from, let's see, you know what, I need to draw this over a little bit more. Okay, so I went to 13, but I need to go to 15. So it's hard to see on this small graph. So this dot is actually right here. That doesn't matter until you get to the position graph. Yes. So the 10 meters in this problem is the starting position. Okay. All right. So 15 to 27. So here's 24, 26. Here's 27. Okay. So there's my other graph. Now this is the velocity versus time graph. Okay. And this is my little mess up here. So these two dots are, if I'd done it in pencil, I'd erase it. Okay, now we go to the displacement versus time graph. Now the cool thing is with these graphs, the time, the x-axis is always going to be the same. So you can go ahead and you don't have to do it. You don't have to figure anything out. Go ahead and just copy it. Okay, so there's my time. On my y-axis, I've got position, or you can label it displacement. Remember, positions are displacements. Positions are a subset of displacements. They are displacements from the origin. Now, they give us some extra information here. They say that she starts at 10 meters. We need to figure out how does she change her position so we can label the y-axis, the y-axis. So we know that on a velocity versus time graph, the area under the curve, okay, is the displacement, delta D. So the area that we're talking about for the first part is this area from this line to 0. So this rectangle. And then for the second bit of data of motion, it's this area. It's from y equals 0, the line y equals 0, to this trend. Okay? Now, what does that boil down to on the graph? Well, it boils down to the velocity multiplied by the time, because the area of this rectangle, delta D1, I'm going to call it, it's just equal to this height, which is velocity, and that's going to be 4 meters per second, and it's going to be for 0 to 15 seconds. Yeah, it goes from 0 to 15 seconds. You're traveling at 4 meters per second, and that is 60 meters. So wherever we start from, we travel 60 meters if we travel at 4 meters per second for 15 seconds. Okay? Now, I want you to recognize, hopefully, that if we did not know where Chrissy started, if we didn't know that she started at 10 meters, we wouldn't be able to know where she ended up. But we definitely could tell how far she traveled and in what direction she traveled. We know that she travels in the positive direction for 60 meters. Now, we also, because of the extra information, we know she started at 10 meters, which means she ended up at 70 meters because she traveled 60 meters. But if they hadn't told us this 10-meter thing, we would just have to assume she started at 0, which would be okay. Okay, but they give us a little bit of extra information, which is her starting position. This velocity versus time graph does not tell you where you start or end. It just tells you how far you go and in what direction you go. Okay, the next displacement is caused by this different motion. I'm going to call it delta D1 or delta D2. And it's the area of this rectangle, which is from 0 to negative 6. So we have negative 6 meters per second times this length of time, which is 12 seconds. And that is negative 72 meters. Why did I? Because it says she went back down at negative 6 meters per second for 12 seconds. So I just plotted what was told in the paper. Okay, now we're going to take this information and we're going to put it on the position versus time graph. So we got to think about this. There are 3 things that we need to show on the position versus time graph. We need to show that she started at 10 meters, that she went up 60 more meters to 70, and then she went back down again 72 meters, which means she ends up at negative 2. Right? So our big change is going to be from 70, positive 70, to negative 2. That's what we have to show on the graph. And that's a total of 72 meters. Okay? So, again, we're going to figure out our increments. We got 72 meters, and in my case, I'm dividing that by 16 spaces. Okay? And that's going to go in a little more than 4 times that. So I'm going to round that to a 5. And I'm going to have 5 meters per space. So you have 7.2, so you're going to round up to 10. Okay, you always round to 1s, 2s, or 5s. 10 has a 1 is 1 with a 0. Okay? So each one of your spaces is going to be 10 meters per space. Okay, where are we going to start? Well, our lowest point is negative 2.
So wouldn't that work if I would have started at 7? Like, do I have to round?
Okay. Do you want to count by 7s on a graph? Well, one of your positions that you're graphing is 70, and one of them is negative 2. The negative 2 is not going to be on any line. So what I would like you to do is to number your axes by increments of 1, 2s, or 5s. Multiples of 1s, 2s, or 5s. Okay? Then that makes it easy to count. It makes it easy for you to find the location in between the lines, that kind of thing. Okay? That's just typically how it's done. You label with these increments, 1, 2s, or 5s, because it's easy to count by 1s, 2s, or 5s. Okay, so I know my increments, you know your increments. We have to make sure that we can put -2 as the lowest space. So for my case, I'm counting by 5s. So I'm going to start with -5, which is below the lowest point that I have to plot. You are going to put -10, because that's below the lowest point you're going to have to plot. And we've got -5, 0, 5, 10. You're going to do -10, 0, 10, 20, 30, 40, 50. I'm counting by 5s. Then I have her located at 10 at 0 seconds. And then after 15 seconds, she's at 10 plus 60, which is 70. And then after 12 seconds more, or 27 seconds, she is at 70 plus -72, which is -2. So she starts at 10, which is given by the problem, and then after 15 seconds, she's at 60. She travels 60 meters, so 10 plus 60 is 70. And then for the last 12 meters, she travels in the negative direction, 72 meters. If she's at positive 70 and she travels negative 72 meters, she ends up at -2. And so I end up down here at -2. And so then I'm going to draw my trends. And I'm going to label this P versus T, or...
So is that just for close?
Say it again?
Does she go down to -2 for close?
She travels for the last 12 seconds toward -2, and at the end she ends up at -2, which is at 27 seconds. She travels 15 seconds in the positive direction, and then she travels 12 seconds in the negative direction.